Okay, let's take a look at some of the questions on the Unit 5 review on exponential functions. So for number 1, we want to find a growth or decay law for each of the following functions. And we're given a table of values for part A. We can see that the function is growing because the g of t values are increasing as t increases, but we want to know what that growth factor would be. So we'll find it by taking the quotient of two consecutive g values. Okay, so I can say 19.2 divided by 12, and I can do that because the difference in the t's is just a 1. Okay, and that gives me 1.6. And therefore, our function equation g of t is equal to a times b to the t, where a is 12, and then b is 1.6. Okay, in part B, we'll do the same thing. I'm going to label these ordered pairs, and so that first point, the y-intercept, is at 500. And then when x is 1, the y value is 100. Okay, so we can find b by taking the quotient of two consecutive y coordinates, and so this will be 100. Remember, just kind of work right to left with those, so 100 over 500, or 1/5. And our formula, we'll call it f of x, is equal to a times b to the x, and in this case a is 500, which is the y-intercept. Okay, in number 2 it says determine the y-intercept of the function and whether the function is increasing or decreasing, and we can learn those things from a and b in our exponential function equation. Okay, so first, kind of recognize that it is an exponential function, each of these, and so you want to make sure that it's in this format, y equals a times b to the x, where b is greater than 0 and not equal to 1. Okay, so for part A, f of x equals 6 times 1.2 to the x. A is 6, so that's the y-intercept. And b will tell us if the function is increasing or decreasing. So because b is greater than 1, this function is increasing. Okay, next, g of x is 35 times 0.5 to the x, so the y-intercept is 35, and this function is decreasing because b is between 0 and 1. Okay, and lastly, h of x, our y-intercept is 2, and then the function, I don't know, it kind of looks like it should be increasing, but you want to take the base along with the exponent, in this case the coefficient of x. So really we're looking at 3 to the negative first as our b. And that's 1 over 3 to the first, so 1/3. And therefore, this function is decreasing. If you ever question, if you wonder what it's doing, just graph on your calculator. Okay, for number 3, we're asked to graph the functions and then find the range of the function if you're given a domain from x equals -3 to 3. And so for this first one, I'm just going to enter this in y1. So 2 times 3 to the x, and if I use the standard viewing window, okay, I should be able to see the curve. I know the y-intercept is at 2, and I also see, because b is 3, I could find some other points on the graph pretty easily. Okay, well, you don't necessarily have to graph the function in order to find these values in the range. And so I could just find g of -3 by replacing x with -3. So 2 times 3 to the -3. Okay, and 3 to the -3 is 1 over 3 to the 3rd. And so that's 1 over 27, so 2 times 1 over 27 are 2 27ths. And then g is 2 times 3 to the third. Okay, 2 times 27, or 54. Okay, on the calculator, if I've already graphed the function, I can hit the trace button and just type -3 and hit enter. Okay, and that's about 0.074. Okay, which hopefully corresponds with the 2 27ths, and then hit 3 and then enter, and that gives me that 54. Another option is to look at the table. So second graph, okay, so when x is 3, y is 54, and when x is -3, y is about 0.074. Okay, so I would write the range from smallest to largest, and the smallest value is that 2 27ths, and the largest is 54. Okay, number 4, you deposit money into bank first, where your balance after t years is given as this function f of t, which is 150 times 1.06 to the t. Okay, evaluate f of 0 and f of 10 for part A. So f of 0 is 150 times 1.06 to the 0. And any non-zero number to the 0 power is just 1. So that's 150 times 1, or just 150. Okay, and we can just say that this is the initial deposit. Okay, f of 10 is going to be 150 times 1.06 to the 10th. And that's about 268.63. And so after 10 years, the account's balance would be about $268.63. Okay, if we want to find the interest rate, R, we have our B, which is of the form 1 plus R since the balance is growing, and replace B with 1.06 and solve for R. So really you're just subtracting 1 from B. So R is equal to 1.06 minus 1, or 0.06. Okay, and that's an annual interest rate of 6%. In part C, it says, how long will it take until the balance reaches $200? So we'll replace f of t with 200. Okay, and then solve this equation for t. Okay, one way we could do that is by hand, and the first thing that I would do is isolate the power of 1.06 to the t. Okay, and you can reduce that or just leave it. And then we can write this in logarithmic form. So as log base 1.06 of this fraction is equal to t. And now we can use our calculator to evaluate. In order to evaluate this using the log key on the main keyboard, this log key has a base of 10, as it's the common logarithm, and this base that I have been given is a 1.06. So we're going to use something called the change of base formula, and you're just going to take log of the argument, which is that 200 over 150, and then divide by log of the base, 1.06. Okay, and we get about 4.9 years. Okay, number 5, it says the number of students at Salt Creek Elementary School fell by 18% last year, but increased by 26% this year. What was the net change in the number of students? Essentially, what we're doing is looking at the growth and decay factors from year to year. And so the first year, I'll call this B1, the population of the students fell by 18%. So we would use 1 minus R, and so 1 minus 0.18 or 0.82. And then the next year it increased by 26%. So because it was an increase, a percentage increase, use the 1 plus R formula, and that's 1 plus 0.26 or 1.26. Now we're going to multiply these together. Okay, so B1 times B2 is 0.82 times 1.26. And that's 1.0332. Okay, now overall, remember, compare this back to 1, and so I would subtract 1 from this and get 0.0332, and then convert that to a percentage, so 3.32%, and it's going to be growth because this, our new B, our overall growth after the second year, is this growth factor of 1.0332, which is bigger than 1. Okay, number 6 is a similar idea. Okay, so in Veroco's stock is growing exponentially in value and increased by 33.8% over the past 5 years. What was its annual rate of increase? Okay, so we're going to say that increased by 33.8%. Our 5-year growth factor is 1 plus R, or 1 plus 0.338, which is 1.338. Okay, but we want the annual growth factor, so we're really going to take B, this B, and raise it to the 1/5. And so 1.338 to the 1/5 is about 1.05996. Okay, and so refer to the growth rate, and that's going to be, take the decimal portion and multiply by 100, or move the decimal 2 spots over, and so that's 5.996%, or about 6% altogether. Okay, number 7, the number of computer science degrees awarded by Monroe College has increased by a factor of 1.5 every 5 years since 1984. Hey, if the college granted 8 degrees in 1984, how many did it award in 1994 and 2005? Okay, so we want to find a formula. We'll call this A of T. And initially it awarded 8 degrees and increased by a factor of 1.5. So if it gives you a growth or decay factor, you're just going to use it. But this is 1.5 every 5 years, kind of like the last problem. So if it said increased annually by a factor of 1.5, I would just put 1.5 to the T here. But it didn't say that, so we're going to raise 1.5 to the T over 5. Okay, now we can use this formula to make these calculations. So in 1994, that's 10 years later, so find A of 10. Okay, and that is 18. And then 2004, or 2005 is 21 years later. Okay, so calculate 8 times 1.5 to the 21/5. And we'll round, and so that'll be about 44 degrees. Okay, I will skip number 8. Let's take a look at number 9. And if I want to evaluate a logarithm without a calculator, I'd probably rewrite this in exponential form. And so you could just say this is equal to x, our unknown. Okay, and we start with a base. And so 2 to the x is equal to 16 is how I'm going to rewrite it. And I just think about our powers of 2. So 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, so that must mean that x is 4. Okay, so our answer is just 4. Okay, you can use a similar idea for these others, so I won't go through every single one, but another option is to double check yourself on your calculator. And so everybody should be able to use this change of base formula. So log of 16, and then divide by log of 2, and hit enter, and there's our answer. Okay, number 10, we want to rewrite the equation in logarithmic form. So we're going to write log and then kind of just imagine 3 blanks, write them down on your piece of paper, that the base of the power is going to correspond with the base of the logarithm. So I'm just going to put a 2 there. Okay, the exponent, okay, is the answer in our logarithm, and so we'll put a 5 on the right. Okay, and lastly, the power evaluated, which is that 32, is going to be the argument of the logarithm. Okay, so altogether, log base 2 of 32 is equal to 5. Okay, number 11, we're kind of doing the opposite, and so start with the base, raise to the power, which is on the opposite side of the equal sign, and then come back around to the argument. Okay, so altogether we get 3 to the second is equal to 9, which is a true statement. Okay, number 12, a water tank has been sanitized by pouring chlorine bleach. Bleach is toxic at that level, needed to sanitize, so you need to flush out the tank using clean water. The result is that after each hour of flushing, there is a 19% reduction in the bleach concentration. Assume that when you begin flushing, the bleach concentration is 150 milligrams per gallon. So we want to write a formula for the concentration. So I'll just say C of T. Okay, so we write the initial concentration first, and then times a B raised to the T. But we have to figure out what the decay factor is. And in this case, because it is decay, it's going to be 1 minus R. So 1 minus 0.19 or 0.81. Okay, in part B, it says you can safely use the water tank for drinking purposes when the bleach concentration is below 0.7 milligrams per gallon. So how long should you flush the tank? Okay, so we have a concentration that's given, this 0.7, and just substitute it into the formula. And we're going to solve for T. Okay, so by hand, I would isolate the power. So I would get 0.7 over 150 is equal to 0.81 to the T, and then use a logarithm. So log base 0.81 of 0.7 over 150 is equal to T. Okay, and then you can use the calculator. So we'll just say log of that fraction, 0.7 over 150, and close your parentheses, divided by log of 0.81 is about 25.5 hours. Okay, and then part C, it says what is the percentage reduction of bleach concentration per day? Okay, so remember what we were given was the reduction over the course of each hour. So 19% each hour. So instead, we're going to take that 0.81 that we were given and raise to the 24th power because there's 24 hours in a day. And we get about 0.00636. Okay, well this is not our answer. That we're going to calculate r by subtracting this number from 1. So 1 minus 0.00636 is 0.99364. Okay, and altogether over those 24 hours, that's about a 99% reduction. Number 13, according to the BP Statistical Review of World Energy 2006, the United States produced 7,733,000 barrels of oil a day in 2000 and 6,830,000 barrels daily in 2005. We want to find an exponential model that gives the number of barrels of oil produced a day in thousands as a function of years after 2000. Okay, so we can write this information in ordered pair form. So 0 could be the year 2000, and that's 7,733,000 barrels. Okay, and then in 2005, that's 5 years later, and so 6,830. Okay, and so we really already know, if we're writing our function, we'll call this Q of t. We know what Q naught is, or the initial amount, which is the 7,733. But what we don't know is B, and so we're going to use a little formula to calculate B really quickly. Okay, so what we could do is find the quotient of our y's, so typically y2 over y1, and raise to the reciprocal of the difference in the x's, so 1 over x2 minus x1. Okay, so in this case, we're going to take 6830 over 7733, and then raise to the 1/5. Okay, and altogether, that's about 0.975. Okay, in part B it says use the model to predict the number of barrels in 2007. And so 2007 is 7 years after the year 2000. So we're going to let T be 7. And we get about 6,477, and that'll be in thousands of barrels. Okay, and lastly, according to your model, when will the production of oil be reduced by half? Okay, so we can, the good news, just knowing the relationship between the initial and later amounts, we can just go ahead and put a 1/2 on the left. Okay, so 1/2 is equal to 0.975 to the t. Okay, and as a logarithm, okay, log base 0.975 of a half is equal to t. Okay, and just calculate that. That's about 27.4. So it'll take about 27.4 years from the year 2000, and so that'll be the year 2027. Okay, and let's take a look at one more. This is number 17. So we want to combine into one logarithm and simplify. Okay, so the first one, part A, we have log base b of 18 minus log base b of 9. So we're going to use the quotient rule, which says we can combine these logarithms into one by dividing the arguments. So we're going to divide the 18 by the 9. Okay, and then simplify. So log base b of 2. Okay, so for part B, we have 7 log base 2 of t plus 6 log base 2 of r. Okay, now the first thing before we do the combining, we want the coefficient of the logarithms to just be a 1, and they're not yet. So we're going to use what's typically called the power rule. Okay, so to rewrite each of these arguments, so this is log base 2 of t to the 7th plus log base 2 of r to the 6th. Now we can write this all together as one logarithm using the product rule. And so what the product rule says is that when you see this sum of two logarithms that have the same base, you can rewrite it as one logarithm with a product of the arguments. And so we're going to multiply t to the 7th by r to the 6th.